I'll refresh your memory, right? So, the title of this section is Systems of Linear Equations. So, when I'm talking about linear equations, what type of graphs am I talking about? I'm talking about lines. Yeah, I'm talking about lines. Easy lines, okay? So, a system, then, you may recall, is when we solve two or more lines together, right? That's what a system is.
Oh, yeah.
It's when we solve two or more lines together at the same time. Okay? So, what's an example? Well, here's an example, right? You're always going to know you're dealing with a system because they're going to give you these brackets here. Okay? And since we're dealing with lines, every system that we're dealing with in this particular section has to be some form of a line, whether the general form, slope-intercept form. It has to be some form of a line. So here's an example, right? Let's do x plus 2y is equal to 2. And the other one, let's do x minus 2y is equal to 6. Is it starting to make a little bit more sense now? You've seen this before? Okay. All right, well, you may recall the first thing that we do when we're solving a system is we figure out whether or not a given point is a solution to the system. So here's what I'm going to do. I'm going to give you a point, okay? And here's the point that I'm going to give you. It's going to be -4, 3, okay? -4, 3. Here's the question that I would like you and the person sitting next to you to think about right now, right? Answer yes or no, this point is a solution to the system, and then state your reason why you think it is, okay? So talk to someone next to you and say yes or no. Don't shout it out yet, though. Let's recap everything we just heard. Many of you guys said no. What's the reason you guys said no? Yeah, okay, so we realized that, how do you know, well, when you say it works for the first one, how do you know that this works for the first one? What do you mean by works?
I think you plug in
Yeah.
-4 as x.
Yes, you have to plug them both. You have to plug x and y. Remember, -4 represents x, and 3 represents y. You plug 3 and -4 in respectively for the y and the x, and you see if it makes the equation true. It does work for the first one. It doesn't work for the second one. Kind of a trick question. So the answer then total is no. This is not a solution for the entire system. Okay. Let me give you another one. You determine whether or not it's a solution to the system. Okay. I'm going to give you 4, and I'm going to give you -1.
Yeah.
Okay, ready, set, go. Okay, for the second one, for 4, -1, you should have realized that yes, when you plug 4 and -1 to the top equation and the second equation, it makes both equations true. It makes both of them true, so therefore, 4, -1, yes, is a solution to that system. Everyone agree with that part?
Yes.
Okay, awesome. Okay, if your calculator has R's here, then that means you're still in polar mode. Does anyone's calculator still have R's in it? Okay. Then the way that you change it is you go to mode, and there it is right there, the red button. You can see the last one I pushed, okay? And you want to make sure that your calculator is in function mode. And function mode is like the fourth one down, so just go to the word function and highlight it and push enter, and then it puts you back into function mode. You can check by going to y equals. So if I'm interested in graphing this system, notice that the calculator only allows me to do things that are solved for y. So what do I need to do to both of these equations here? I have to solve them both for y. Exactly. Okay, so help me out really quickly. Let's just solve these both for y. I'll do it in this orange color here. So if I've got x plus 2y equals 2, then 2y equals -x plus 2. So y equals -1/2 x plus 1. Did I do that right?
Yeah.
Okay, good. We're going to plug this into the calculator right now. Please follow along and plug this in as well. Okay. We're going to get negative. So the negative is the button below the 3. Negative. And then 1/2, you can just put 0.5 because that's 1/2. The x button is up here underneath mode. So I have -0.5x and then plus 1. Okay? So far so good?
Yes.
Awesome. Great. Now let's do the other one. All right. So then the other equation I had was this. I had x minus 2y is equal to 6. So -2y equals -x plus 6. So y equals 1/2 x minus 3. So let's plug that one in as well. All right. So the next one down, I'm going to have 0.5x and then plus 3. Take a moment right now. Make sure yours looks like mine before we go on. Otherwise, why is it plus 3? Because of that right here. I divided both sides by -2. and I got negative 6 divided by, or 6 divided by negative 2, I got negative 3. What did I put in? Oh, yeah. Oh, it should be a minus. Yeah, thanks, minus. I thought you said why is it a minus 3? Oh, yeah. Okay, everybody good? Now hit zoom 6. We hit zoom 6 so that we were all staring at the same screen. Otherwise, our windows could be off, and we might not all be looking at the same picture. Okay? So there's mine. Is that what yours looks like too? Yes. Okay, what do you notice about this particular graph?
They intersect.
They intersect somewhere. Where do you think they intersect? It looks like 4, negative 1, right? But it's kind of hard to see right now. Check it out. Your calculator can actually give you that exact value. I'm going to show you how to do it. So we're going to hit the second button. So from the screen of the graph, we're going to hit the second button. And then we're going to go hit the calc button, which is trace up in these top 5. And look at the options that you have. Which one do you think we want? Yeah, option 5. So the cool thing about this calculator, you can just push the number 5, and it automatically takes you to the intersection point. Well, not yet. It takes you back to the intersection mode. So you should see this little black little dot blinking in the middle of your screen, right? It might not be black if it's not colored, but this little dot blinking, right? It's asking you for the first curve. Well, that just means that, in this case, our curves are just lines. So it wants to make sure that the calculator sees the 2 lines that we're looking at. So yes, that is the first line. And I wanted to see where these intersect. So all you have to do is push enter to say yes. And then you'll notice that the graph automatically jumps down to the other curve, or the other line in this case. And so you're like, yep, that's definitely on there. So we're going to hit enter again. And then the calculator allows you to guess if you want to. So you can actually move the cursor around and try and guess. It's just what the calculator does. You don't have to guess if you don't want to. But just push enter one more time and check it out. It points us right to the intersection point, and then down below, you'll notice it says x is 4 and y is negative 1. So I want to make sure that you guys understand that the solution is not really a number, it's a point, it's a location. It's a location. So look, we have 4 and then we have negative 1. Okay, so far we've seen that we can see if a point is a solution. We can solve a system by graphing. The next method that we always talk about when solving systems is called the substitution method, okay? And the substitution method is nothing more than what it is in a sports event when you substitute one player for the other, right? You exchange one for the other. It's the exact same thing here. So notice that in this system, right, I have an equation where x in the first one is equal to 3y minus or plus 7. And then I can see that in the second equation there's an x over on the left-hand side, right? Okay, so you're allowed to actually substitute one in for the other. If they're both equal to x, then they have to be equal to each other. So the method goes like this. You can actually take the information and plug it straight in to create a new equation that would look like this. I'm going to replace or substitute this x for 3y plus 7 and set it equal to 2y plus 1. Why is this nicer than what we did before? There's a reason why this is much nicer.
Because you don't have to do 2 things.
Well, what do you mean by 2 things?
Like you don't have to deal with 2 equations.
It's not just guesswork.
It's not just guesswork, but what do you notice about this equation? It only has what? It's all in terms of y. Yeah, so therefore we can solve it because it's all in terms of y. So I'm going to do some algebra. So I'm going to subtract 2y from both sides. So I'm going to get y is equal to negative 6. That's what I'm getting for that one. All right? All right, are we done?
No.
No, why are we not done?
Because you have to plug in
No, sir.
the-
You got to plug it back in, exactly. So we're going to plug it. You know what? It doesn't matter which one you plug it into. It doesn't matter. You can use the top one or the bottom one. If it's a solution, it'll work for both, right? Because we just learned that in box 1. So therefore, I get this. X is equal to 2 times negative 6 and then plus 1. So x has to be negative 12 plus 1. So that means that x has to be negative 11. Good. So if I were to graph this system, what would I expect to see?
that it intersects.
They would intersect where?
At negative 11.
At negative 11, negative 6. So this would be the answer for us there. Okay, let's try and solve that one on your own. Tell the person next to you what you got. Put your hand up when you're done. I'll come by and check it out for you. Okay, here is what most people did to solve this equation, right? They realized that every 2x is worth a y. Okay?
no, I forgot.
Every 2x is worth a y. Because if I just move the y over, then I'm going to take this information and I'm going to plug it right here. So I see a y. So I get 4x plus 3. Substitute the value of y with a 2x. And that's equal to 0. So I get 4x plus 6x is equal to 0. So 10x is 0. Therefore, x is 0 if I divide both sides by 10. But I'm not done yet because I have to substitute back, right? So plug it right here. And you get 2 times 0 equals y. Therefore, y equals 0. And you guys, it's okay to have the location 0, 0 be a solution. It's just the origin. That's okay. Don't be like misdirected by that, okay? All right, I want to bring us attention to this over here now. So, check this out. I've got 2 lines that I have graphed, all right? And I've animated both of them, so I'll stop animating them for right now. Okay, I'm just going to stop them randomly here. And there, and there. Okay, so I've now stopped them. So I have these 2 lines over here that represent a system, right? How many solutions does this system have? It has 1. How do you know that? Because they only intersect in one spot. So here's the question I have for you, okay? What would it take for me to have a system that has an infinite amount of solutions rather than just one solution? Kenzie, what do you think? They're the same line. So if I move all of these to the same point, like say 0, for example. Well, if I move this one up to 0 as well. Boom, can I do that? What's this one going to do? Is that going to work for me? There, okay. So I've moved everything to 0, right? If I move this one all to 0 as well, all of my points here, notice what's happening to these lines. They are becoming what? They are becoming exactly the same line. And there it is right there, okay? So look, I have all my, oh wait, sorry. Where'd it go? There it goes, okay. So 0's, it kind of goes away, right? If I move them all to 1, then they all become the same line. See right there? So I've got that one, or 0.9. Kind of hard to do with these little sliders. And move these all to 1. Okay, next question I have for you is what would it take for me to create a system? There we go. Ah, come on.
Parallel line.
There we go. Ah, there we go. That's so hard to do. What would it take for me to create a system that has no solutions?
Parallel line.
Parallel lines. So if I just move this one to there, now all of a sudden I have a system that has no solutions because they never intersect anywhere, right? So I want the visual to correlate to the math that supports it behind it, okay? So it is possible for systems to have one solution where they cross, no solution, where they're infinitely many solutions. Okay, so in addition to the substitution, there's another method that we're going to learn today. It's the addition method. Some people know it as the elimination method. You guys know that one as well? Okay. So in this, the idea behind the addition or the elimination method is to actually just do some algebra to eliminate one of the variables. So there's like 2 different options you can take for the addition method in this particular case. You'll notice that both of the x's, right, the coefficients in front of the x's are 3's. So what would it take to add those together so that they'd go away? Make one of them negative, right? That's one way we could do it. The other option is to notice that the y's have automatically different opposite signs. So how could you make those go away? Multiply which one? The top by 3, or the bottom one by what? A third, right? That would also work too. Okay, so most people would go the first route though. So which one do you want to eliminate? The x or the y? It doesn't matter to me. You don't do the x's? All right. So in order to make that happen, we need to multiply the entire equation, one of them, doesn't matter which one we do, by -1. It doesn't matter which one we do, we just have to do one of them by -1. So that would give me negative 3x minus 2y equals negative 14. So far so good? If we leave the bottom equation alone, we'd get 3x minus 6y equals 10. Now, if I think about adding these vertically, keeping my x's all lined up and my y's all lined up and my answer all lined up, look what happens. I get negative 3x and positive 3x. Well, that goes away. That's why they call it the elimination method, but in this book calls it the addition method. Doesn't matter which way you want to call it. So negative 2y and a negative 6y, if I add those together, that's worth negative 8y. And then on the other side, if I get negative 14 and 10, I get what? negative 4. So if I divide both sides by negative 8, I see a y is just a half, right? Okay? Not done yet because I have to go back in and always solve for x, but I'm going to go ahead and choose to put it right there. So if I do 3x plus 2 times a half, then I get 14 out of all this. So 3x plus, what's half of 2? Just 1, right?
Yeah.
That's 14. So then 3x is what? 13. So x is equal to 13 thirds. And you know what? It's okay to have fractions in our answers as well. So the location of this particular answer would be 13 thirds, comma, 1 half. And we're okay with it. Okay, practice using the addition method, or some people call it the substitution, whichever one. Practice right now, and you have a couple of options available to you. So go ahead, try that one. Tell the person next to you. You should have got -2, -4 for an answer. Does that sound good?
Yeah.
Everyone got that? All right, great.